Creating an MLOps pipeline is an automated, reproducible, and scalable process for building, training, deploying, and monitoring machine learning models. This guide will walk you through the steps to create a complete MLOps pipeline using popular tools and frameworks. Prerequisites: basic understanding of machine learning concepts, familiarity with Python programming, basic knowledge of Docker, Kubernetes, and CI/CD concepts. Step-by-step guide to creating an MLOps pipeline. Step 1. Problem definition and data collection. Define the problem. Identify the business problem you want to solve. Define the objectives and metrics to evaluate the model. Data collection. Gather relevant data from various sources. Ensure data quality and integrity. Store data in a structured format, such as CSV or a database. Step 2. Data pre-processing and exploration. Data cleaning. Handle missing values, remove duplicates, address outliers. Data transformation. Normalize or standardize data. Encode categorical variables. Perform feature engineering. Data exploration. Use statistical and visualization techniques to understand data distributions, correlations, and trends. Tools: Pandas, NumPy, Matplotlib, Seaborn. Step 3. Model training and validation. Model selection. Choose appropriate machine learning algorithms based on the problem, such as regression or classification. Model training. Split data into training and validation sets. Train multiple models with different hyperparameters. Model evaluation. Evaluate models using cross-validation and metrics, such as accuracy, precision, and recall. Select the best performing model. Tools: scikit-learn, TensorFlow, PyTorch. Step 4. Version control and experiment tracking. Version control. Use Git to track changes in code and configuration files. Experiment tracking. Use tools like MLflow to log experiments, including hyperparameters, metrics, and artifacts. Tools: Git, GitHub, MLflow. Step 5. Containerization. Dockerization. Create Docker files to containerize the machine learning environment. Build Docker images for training and inference. Docker Compose. Use Docker Compose to manage multi-container applications. Tools: Docker, Docker Compose. Step 6. Continuous integration and continuous deployment, or CI/CD. CI/CD setup. Set up CI/CD pipelines using tools like Jenkins, GitLab CI, or GitHub Actions. Automate the process of building, testing, and deploying Docker images. Pipeline steps: build the Docker image. Test, run unit tests and integration tests. Deploy the model to a staging or production environment. Tools: Jenkins, GitLab CI, GitHub Actions. Step 7. Model deployment. Deployment options. Deploy the model as a REST API using Flask or Fast API. Use cloud services like AWS SageMaker, Google AI Platform, or Azure ML. Kubernetes. Deploy the Dockerized application on Kubernetes for scalability and reliability. Use Helm to manage Kubernetes applications. Tools: Flask, Fast API, Kubernetes, Helm, AWS SageMaker, Google AI Platform, Azure ML. Step 8. Monitoring and maintenance. Monitoring. Set up monitoring for model performance and infrastructure. Use tools like Prometheus and Grafana for metrics and visualization. Logging. Implement logging to capture important events and errors. Use tools like LKStack, which includes Elasticsearch, Logstash, and Kibana. Model retraining. Monitor model performance and retrain the model if performance degrades. Automate the retraining process using the CI/CD pipeline. Tools: Prometheus, Grafana, ELKStack. Example pipeline implementation. Below is an example implementation of an MLOps pipeline for a hypothetical regression problem using Python, Docker, Kubernetes, and CI/CD tools.